All right, I wanted to do a problem all the way through from section 3.3 in Algebra 2. This is problem number 3. There's 3 parts to it, so if you notice you're only doing the odds on 1 through 11, it's because there's a lot to do on each problem. I'm going to do this one as an example, and you might want to refer to your book. I just abbreviated the instructions here just as like little reminders to me of what I'm supposed to be doing on the video. So if you can't read something, look at your book for the instructions. Part A, here we've got an equation here, and one thing that I noticed about this equation starting out, it is in this point-slope form. And I noticed it is, but one of the things that gave it away to me was that there's this parentheses right here that I'm outlining in green, and then I noticed the y wasn't by itself on one side. That's how I kind of recognized the pattern there. Now, this is a new form for us, but it's a very important form. It's a really nice form because it means that if I get the slope in any point, I can write the equation. I don't have to have the y-intercept anymore if I have this formula. It works out really great. Another thing is this is the form of an equation that we use it more and more in pre-cal, and then in calculus it's almost the only form we use, because in calculus we're always finding slopes and writing equations, and this is the form that we use. So it's a very important one, and a lot of people think, oh, I just need y equal mx plus b, but not really. This is even maybe as important or more important when you get into upper level math. Okay, so now if I look at this formula and I rewrite this equation, my y plus 4, it's supposed to have a subtraction sign on it. Isn't a plus equal to a minus, this plus 4 up here? And then if I look at the formula, there's supposed to be a subtraction sign in there, and there is. The reason I'm pointing that out is it's really hard for people to get used to picking the points out. In this formula, there is a point, x1, y1, but there's a subtraction sign in front of each point. So what I did was I came through here and made sure I had a subtraction sign so I could clearly pick out the point. If it's a y plus 4, I have to think of that as a minus 4. It's kind of, you might think that your y value in this equation, by the way, the y value is grouped with the y, and the x value is grouped with the x in the parentheses. And if you look at the formula, we see them. This is my x1 here, and my y1 is here, but it's kind of got to think of it as, well, if I had written that as subtraction, it would have been y minus 4. So my y1 value here is really negative 4. It's opposite of what it looks like in the formula because of the subtraction sign. And my x value over here is actually a positive 3. And again, it's opposite of what you might think. You might think it's a minus 3 because you see that subtraction sign in it. And we're used to pulling off subtraction and adding signs as signs of numbers. But this formula has these subtraction signs in them that I'm highlighting in red. And that makes it a little tricky to deal with. And a lot of your equations from Algebra 2 on up are going to have subtraction signs in them. Most of them do. And so you kind of got to get used to thinking about, if the formula has a subtraction sign in it, I got to look at my equation and kind of think, okay, how did that affect the number I'm picking out? Because if you remember, in point-slope form, I get the point from the x1, y1. That's just a point on the graph. Remember, we talked in class about how you could look at x1 as the x of the first point you're given and the y of the first point you're given. And they're given to me in this equation. They're just kind of hidden in the equation. And so the x1 value is this 3 over here. If you look at the formula, it's grouped with the x. And the y1 value ends up being minus 4 here because I had to think, well, it looks like it's plus 4, but that subtraction sign in the formula means I need to think of it as y minus 4. All right, so now part A wanted us to graph this, and so it's 3, negative 4, and hopefully I can do this. It's hard sometimes for me to see what I'm doing on this small of a graph, but it's 3, negative 4, looks like it's down here or close to it, and then I've got my slope. Now this is the equation of a line. Again, remember, all these equations we're studying are equations of lines, and so I can count my slope by going, and I'm going to use a different color here at count just so you know it's not a point. My slope is sitting right in front of the parentheses that have the x in it, so it's the 7/2 that I'm circling. So up, remember, slope is rise over run. One of these days I'll get the stylus figured out. So it's 7/2. So we're going to rise 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to run over 2, so run to the right 2. So I'm going to put a red dot where I ended up. Remember, those purple dots are just me counting. They are not line. They're not points on the graph. And then I can graph this line, and I want to show that it goes on forever and ever because they didn't tell me to just graph it for certain x's. My domain then is all real numbers, just to bring in some of that language we had in the last section. That was supposed to be a 2. All right, so I've done part A. I graphed it, and they wanted me to clearly show the point that was in the equation, and that was this point that I graphed first, and then the slope, which I got from the equation. If I had a problem where they gave me a point and a slope, I could just take this formula right here and plug it in, and that's what you're doing on 11 through 14. If you notice, you're just sticking stuff in. If I have time, I'll put that one on this video. I'm not sure if I'm going to have time to do that or not. This one takes a while. We're supposed to take that equation, and part B says we're supposed to write it in slope-intercept form. Well, what is slope-intercept form? Slope-intercept form, and I'll come over to the side and write it, it is y equal mx plus b. That's slope-intercept form. Now, what is unique about slope-intercept form is that the y is by itself on one side. So if I want to put my equation in slope-intercept form, I need to get the y by itself and then do any simplifying that I need to do. So here we go. Let's do that. To get the y by itself, it has a plus 4 with it. Let's move it to the other side, minus 4. Now, here's where a lot of people make a mistake. They want to put that negative 3 and that negative 4 together, but you can't do that. That negative 3 is in parentheses, and it's being multiplied by 7/2, so you can't do that. You have to think PEMDAS here, which is the reason in Chapter 1 they had you reviewing PEMDAS, because they know the mistakes students make, okay? So we've got to get all this simplified. So first, PEMDAS says do parentheses. Well, there's not really anything inside of parentheses to simplify. Then it says do exponents, but there's none of that. Then it says do multiplying or divide from left to right. Well, I have some multiplying here because if you recognize this 7/2 in front of these parentheses right here, that's the distributive property, and we multiply in the distributive property. So we're going to do that next. That would be 7/2 x. And then remember, I have to also multiply 7/2 times the minus 3. A positive 7/2 times a negative 3 would be a negative 7 times 3 would be 21 over 2. And then I've got minus 4. Okay, so we don't have it in slope-intercept form yet because we still got to simplify and combine those numbers. I do know my slope is 7/2, but I knew that from the first problem, didn't I? So I can tell that, I'm kind of on the right track here. Still got my slope as 7/2. But if I want to have my y-intercept, I need to get a common denominator and combine these numbers here on the end. So I'm going to multiply 4 by 2 over 2. I'm going to come over here to do the math. That's negative 21 over 2 minus 8 over 2 would be negative 29 over 2. So my equation ends up being y equals 7/2 x minus 29 over 2. My y-intercept here is not very pretty. We wouldn't have wanted to graph from this form because that would be kind of hard to graph that point and then count up 7 over 2 because it's not falling on those little square, corners that are easy to count. My y-intercept here would be x is 0, y is negative 29 over 2, and you could think of that, if it helps, it's like negative 14.5, yeah, negative 14.5. Let me scribble that out and do that to the side here, negative 14.5. That would not be easy to count off and graph. Sometimes it's easier to graph from this original, point slope form up here because that point was nicer. The point 3, negative 4 would have been easier to graph and count from than this negative 14.5 would be. So that's part B, putting it in slope-intercept form. To put something in slope-intercept form, what do? You solve for y and you simplify, and then it's in that form. So solve for y and simplify. Hey, it almost rhymes. Well, it does rhyme. Solve for y and simplify. That's how you put something in y equal mx plus b form. I'm going to quickly try to go ahead and do the part C and see if I can't fit it on the video. If I talk fast, you may have to slow it down. We had y equals 7/2 x minus 29 over 2, didn't we? Okay, so hopefully I wrote that down right. If I want to put it in standard form, that's what part C is asking me to do. When they tell you to put in ax plus by equals c, they want the x and the y on one side. Here they are. They want the constant, the plain old number with no variable, on the other side. And most books tell you that you just have to have the coefficient of the x and the coefficient of the y be whole numbers. You don't want fractions there. It's considered impolite math communication. And you want a, the first number, to be positive, just because, again, nobody likes to get an equation that has a negative out front. So when we put it in that form, we're going to clean it up since we can do that, okay? So first of all, if I look at this, my x and the y aren't on the same side. I know that I want this x term to be positive, and it is positive where it's sitting, isn't it? So what I'm going to do is leave it alone so it stays positive, and I'm going to subtract y from both sides. Now, y minus y does cancel out, but it also adds up to 0, and you're going to want to put that there because you can't leave an empty blank on the left side of the equal sign. That's just not good. So here's what I have now. I know that I want the number part, this negative 29 over 2, I want that to go over on the other side. So to get it over there, what I'll do is I'll add 29 over 2 to both sides. Okay, so now I have 29 over 2 is equal to 7/2 x minus y. And really, let me go ahead now and write 7/2 x minus y is 29 over 2, because it's also polite to put your x's and y's on the left-hand side. That's how we're used to seeing them, and our brains know what to do when it sees it that way, so it's just polite to do it. Now, I'm almost done. The problem is I'm not supposed to have a fraction in front of my x or y, and the x has a fraction. Your book wants you to make it where you don't have any fractions at all. So that works out in either way is fine with me when you do a test, but here it works out really nicely, because if you look in the denominator, you have 2's there. Well, I can get rid of those 2's. If I multiply every single term in this whole equation by 2, I get rid of the fractions. 2 times 7/2 x, which you can write it like this if you need to, the 2's would cancel out, and I'd end up with 7x. I'm going to have to squeeze that in down here because I'm running out of room. Then you would say minus 2 times your y, so that just becomes minus 2y. And then you would have to say on the other side 2 times 29 over 2. And the 2's cancel out, and that would be equal to 29. So 7x minus 2y is 29. Why did I pick 2? I wanted to get rid of the fractions, and so I look at the denominator and I multiply by the lowest number that would clear out the fractions. This is called clearing the fractions. Both of these are 2, so if I multiply by 2, everything cancels out. I just need to get those denominators to cancel out. You learned about this in 5th, 6th, 7th grade. It's called the least common multiple. The smallest number that both of those numbers will go into is 2. Okay, and so we're done with that problem. Okay, I'm going to do this problem really fast, but I'm almost out of time. When I'm given a point and a slope, I want to use the point-slope form. And that point-slope form is what this section has been about. The y minus y1 is m times x minus x1. Now, when I do this, here's what I do. I write down my subtraction sign, and I just put a blank where I'm going to plug in that y1. I need to also fill in the m and the x1 here. Now, when I take that point, 6, 3, that is where I'm getting my x1 and my y1. This is one point they gave me, so this is the x of the one point they gave me, and this is the y of the one point they gave me. The x1 goes right here. Look, there it is. The y1 is right here, so I put the 3 here. And now I'm just supposed to put the slope, which is 5, in the blank in front of the x term. So now I have my equation, and I'm done. Those go really fast. You just filling in blanks and labeling things.